What if we wanted to define our own function? Well, in most programming languages, you define your own functions by some sort of syntactic function, this, blah, 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 parenthesis, and all that stuff. In Q, as you might guess, the approach is minimalist. So the way we define a function in Q, I'll do the simplest one, well, one of the simplest one. You use opening squiggly brackets. Square brackets say this is the name of the parameter. Let's multiply it by itself. Closing squiggly brackets says return that value. So yes, this is the squaring function in Q. Could it be any simpler? Actually, yes. We'll get to that shortly. If you want to apply this function to a specific argument, you can just write it next to the specific argument. And the idea here is when you apply a function to a specific argument, in this case 5, it looks for the thing in the square brackets, x, which is an arbitrary placeholder, and everywhere in the body of the function, it substitutes the actual argument 5 for the occurrence of x. So it sees x star x, so it would substitute 5 star 5, and since there's nothing else to do, it just returns it. So that is a simple function in Q. Now, we could also write that with brackets, because lots of programmers in programming languages like to have parentheses or brackets around the arguments, and so that's also acceptable. In functional programming, we tend not to use brackets. We tend to use the function juxtaposed with the actual argument value, and that's the way I personally program Q. But you can use brackets if you want. Just remember, we don't need no stinking brackets. Okay, so that's defining a function and evaluating a function. But yes, there is an even simpler way to do this. In mathematics, we're often content to use x, y, and z as variables, as well as the names of parameters and functions. And if you too are content with x, y, and z, if the name of the parameter isn't meaningful to you, then you can just omit it. In this case, we're saying there are implicit parameters. There are only 3, x, y, and z, because the alphabet runs out. They occur in that order, and so if you're content with using x and or y and or z for a function, you don't have to declare them. They're implicitly declared, and so here is the simplest way to write the scoring function in Q. And now when I ask the question, can it be any easier? The answer is no, right? There's no way to write a function shorter than this that says take a value and square it and return the result. So as they would say, but wait, there's less. This is how we write a simple function in Q. So now we know how to write simple functions. Well, you'd say, but geez, what's missing there? And what's missing is programming frou-frou, right? We don't need anything else that's specific to telling the computer what to do. We've told it what to do. Take an arbitrary x, square it, and return the result.